Hello, welcome to this video. In this video we'll be looking at the dot product of vectors. What is the dot product? The dot product of two vectors, say a and b, is defined as the product of the magnitudes of the two vectors and the cosine of the angle between them. Now that angle between them is the angle measured between the two vectors when they are either emerging from the same point or converging at the same point. So r theta can be acute or obtuse, like you're seeing in both illustrations. Okay, so how do we calculate this dot product? As you have seen in the equation, we need the magnitudes of the two vectors and the cosine of the angle between them, but it might be hard to measure that angle in practice. So let's say our vector A is a1i plus a2j plus a3k, and our vector B is b1i plus b2j plus b3k. So A dot B would be a1i plus a2j plus a3k dotted with b1i plus b2j plus b3k. Now the dot product is distributive, so we're allowed to have a1i dotted with b1i plus b2j plus b3k plus a2j dotted with b1i plus b2j plus b3k plus a3k dotted with b1i plus b2j plus b3k. Okay, so now we have a1i dotted with b1i. So a1 and b1 are just magnitudes of those two vectors. So we'll have a1 b1 times I dot I plus a1 b2 times I dot j plus a1 b3 times I dot k. Similarly, we'll have a2 b1 times j dot I plus a2 b2 times j dot j plus a2 b3 times j dot k plus a3 b1 times k dot I plus a3 b2 times k dot j plus a3 b3 times k dot k. Now from our definition, a dot b is magnitude of a times magnitude of b times cos of the angle between them. So let's look at something like I dot I. The magnitude of I is 1, and so this would be 1 times the cosine of the angle between them, which is 0, and cos of 0 is 1, so this would be 1. So similarly, j dot j would be 1, and k dot k would also be 1. How about something like I dot j? I dot j would be 1 times cos 90, since I and j are perpendicular. Cos of 90 is 0, so this would be 0. So similarly, I dot k and j dot k would be 0, and the dot product is commutative, so the same works for j dot I and k dot I and k dot j. So what does this leave us with? This leaves us with a1 b1 plus a2 b2 plus a3 b3. Everything else dissolves to 0, and so our dot product is simply the sum of the products of the like components. Okay, let's see that in practice in an example. So say we had the vector p, which was given by 2, negative 4, 1, and the vector q, which was given by 4, negative 1, negative 8. P dot q would be equal to 2, negative 4, 1, we dot this with 4, negative 1, negative 8, and that would be 2 times 4 plus negative 4 times negative 1 plus 1 times negative 8, and that would give us just 4. So the dot product of those two vectors can be calculated simply like that. Okay, so now we have the dot product. So what do we use it for? The first obvious application comes from the definition. Since we can calculate the left hand side without using the right hand side, we can get the cosine of the angle and the angle itself by getting the dot product of the two vectors and dividing it by the product of the magnitudes of the two vectors. Let's look at an example here. Say we have the vectors a and b given as those. How would we get the angle between them? So we'd have a dot b, which is 2, 3, 1 dotted with 4, negative 3, 0. This is going to be 2 times 4 plus 3 times negative 3 plus 1 times 0, and this gives us negative 1. Okay, how do we get the magnitude of a? We know that this is the square root of 2 squared plus 3 squared plus 1 squared, which is just square root of 14. And the magnitude of b is square root of 4 squared plus negative 3 squared plus 0 squared, which is 5. And so from the equation above you can see that cos theta is in fact negative 1 out of 5 root 14. Okay, so our theta will be the arc cos of negative 1 out of 5 root 14. Remember, we know that a negative signifies an obtuse angle, and indeed the angle you get here is 93.06 degrees. And so what if they ask for the acute angle? Then if they ask for the acute angle, we would simply take the absolute value of a dot b divided by magnitude of a times magnitude of b, and so our acute angle would actually in fact be the supplement of 93.06 degrees, which is 86.94 degrees. And that's how we use the dot product to get the angle between two vectors. So we want to use the dot product as well to work out a question like the one we've been given below. Now what do we know? We know that a dot b is the magnitude of a times the magnitude of b times the cos of the angle between them. So we had a dot a, that would be the magnitude of a times the magnitude of a times the cosine of 0. And so this would just be the magnitude of a squared. Okay, but we also know that dot product is distributive. So if we had something like a plus b dotted with a plus b, this would be a dot a plus b plus b dot a plus b, and then you could work that out and simplify it. Let's look at the question we've been given. We've been tasked to find the magnitude of 2a minus b. We can square this because we know that this squared is simply the dot product of 2a minus b and 2a minus b, from what we found up here, that the dot product of a vector with itself is simply the magnitude of that vector squared. And so we're using the converse of that to get this. We can distribute this, so this would be 2a dotted with 2a minus b dotted with 2a minus b. This is going to be 4a dot a minus 2a dot b minus 2a dot b plus b dot b. But we know that a dot a is 4 times the magnitude of a squared, and this is simply 4a dot b plus the magnitude of b squared. So you see that at this point we now have everything that we had in the question that we were given. And so this is going to be 4 times 9 squared minus 4 times negative 4 plus 7 squared. And working that out gives us 389. But they wanted just the magnitude of 2a minus b. So this would be the square root of 389 units. So that's how we'd use the dot product to solve a question like that. Okay. The last application really is perpendicular vectors. We know that if two vectors a and b are perpendicular, then this is going to be the magnitude of a times the magnitude of b times the cosine of 90 degrees, which is 0. So that means the dot product of two vectors which are perpendicular is 0. So if you're asked to show that two vectors are perpendicular, you simply have to calculate their dot product. So in this case we would have a dot b, which is 3, 5, negative 1. We're dotting that with 2, 1, 11. So this is going to be 3 times 2 plus 5 times 1 plus negative 1 times 11. This gives us 6 plus 5 minus 11, which is 0. Therefore we can conclude that A and B are perpendicular since their dot product is 0. Okay, so we've covered dot product in this video. In the next video we'll be looking at cross product.